Hey kids, welcome back. I wanted to talk to you about the Mars task for today. It's called flower beds, and it's another one of those problems where we have like a pattern that grows, a pattern that changes, kind of by extension. So if you remember last week, we did some of us I think did the hexagon problem, and the hexagon problem for some of us was all about kind of like the idea of growth, right? And the idea like as it grew the pattern changed, or the pattern stayed the same, but we noticed that the numbers changed. This one's similar, in that we have a certain situation where we're always surrounding a flower bed with white paving stones. So imagine you're planting your garden and you've got a little octagon or a hexagon shaped garden here, six sides, that's a hexagon. And you're taking this hexagon, and that's your garden, the gray part, and around it you want to put paving stones to kind of protect it, right? Now, as you grow your garden, let's say you decide you want to make two flower beds, right? And then you build your paving stones around it, like you're walking around it, kind of thing, right? So your two paving stones now take more or your two flower gardens take more white stones to surround it, right? So, and then as it grows, you keep noticing that the amount of white paving stones also grow, but they don't grow by the same amount, right? They grow by a different amount because you're surrounding the originals by paving stones. Now, this is not a very complicated pattern. It's not a very complicated kind of sequence, which is good because what I wanted to show with this problem to you is that there is a connection between kind of like different ways of seeing a math problem like this. So in this, we can do it visually. So one way for us to show that we understand what's coming next is to draw the next pattern. So if you were going to make four flower beds, so four gray ones, and then surround it by the white paving stone hexagons, how many would it take? Now, when you draw it in your notebook, you can draw that fourth one like as a series of circles if you want. Just as a diagram is fine, as long as it makes sense according to the spacing of what you see here and here. But the idea is that one way to show something is visual. It's to show the picture, right? Here's what it's going to look like with number four. And then you could say, here's what it's going to look like with number five. Another way to start to get at that, which is like the nuts and bolts, the data of a problem, is to go back to a table like we learned about last week. This idea of building a table to kind of highlight what's going on in the pictures. Like a picture takes a long time. A table Filling out a table takes very little time, right? So this is a really efficient way. Drawing pictures of each one takes a while. Making a table is incredibly efficient, which means you can very quickly get across the information you want without a whole lot of effort or without a whole lot of work, right? And that's a good thing because that means you can extend your table. So notice I'm going to ask you to draw the fourth pattern. I'm not going to ask you to draw the fifth and the sixth because it would take too long, but I am going to ask you to predict or to understand how the pattern's growing so you can say what the fourth one, the fifth one, and the sixth one are going to look like. So the table helps you to do that. You notice a pattern. You notice that this pattern seems to continue, and you continue it, and that's pretty simple. So once again, not a difficult thing in terms of when the flower beds grow, so do the white paving tiles. You have to have more of them. When you need more flower beds, you need more white paving tiles to surround them. Now, the thing we're adding to this one, which I like a lot, is this graph. The graph kind of shows basically this as a point. So if I was going to graph the first point, I'd say it's one flower bed. See one right here. And it takes me six white paving stones. So I put a dot right there. So I'm going to do that. So I'm going to, for number one, I'm going to put a dot. Make a blue dot. And I'm going to come down here, and at one flower bed, I have six paving stones, right? Now, I don't have my male pen today, so it's going to be messy, but 1 and 6 is that point right here. So, like, what I just basically graphed is this first point. I graphed this point of 1, right? And then comma 6. So that's my X and my Y. That last part looks terrible, but that's okay. The next one I'm going to graph is going to be 2, 8. And I'll notice that if I go to 2 and go up to 8, it goes to right here. So you start to notice that another way to chart information about a problem is to do it on a graph. And what I'd like you to do in your drawing or in your notebook is to actually make this graph. And I know that's a pain. I know a lot of you are like, oh, really? But it's not that much work, really. You already have the horizontal lines on your line on your notebook. If you have graph paper, that's even better. But making kind of like the with 1, 2, 3, 4, 5, 6, 7, 8, not so difficult, right? And I want you to show how is this thing growing from here to there. So it's kind of seeing that we can kind of read this information in multiple ways. And I think that's really important in math is that you're able to do that. So I'm going to leave you with this problem. I think there's also a bonus on it, which asks you to predict what's going to happen next. Like what's going to happen down at like, for instance, we're going up to 6 with our table. We're going to go up to 6 on our graph. But I'm going to ask you what happens at 9. Where would it be at 9? So what would be the number of white tiles and the number of flower beds? When you're at 9 flower beds, how many white tiles? So I want you to think about that. And I want you to notice that all three of these methods work for showing this kind of pattern growth, and then certain ones show you the information in a different way, right? So I want you to kind of pay attention to that. Okay, enjoy this problem, do the work, actually draw it, spend some time drawing it. The table, the picture, the table, and the graph all need to be drawn. So that's where the effort comes in here. This isn't a really complicated problem. It's more that the effort comes in and you actually building this or drawing this into your notebook, so that you kind of have like a record of it, so you're drawing the table and the graph and the actual picture. All right. Hope you guys have a good day. Good luck with this one. And let me know if you have any questions. Bye.